Hey guys, so today is our new topic of congruence and similarity. Congruence is in geometry, it's when two objects are the exact same, and similarity is when they have ratios, so it could be smaller or larger, but they are still basically the same object, just different sizes. So we're going to start with congruence, which, like I said, is when corresponding angles and sides are all equal. So they can be moved, but they're always going to align. So sides and angles are all equal. Similar shapes have corresponding angles and sides that are not the same size, but they are in proportion with one another. So sides and angles are proportional. Proportion is a comparison of two ratios. So, for example, 1/2 and 3/4 could be considered proportionate. Okay. You have congruence transformation. These are reflections, rotations, and translations. So you have reflections, and rotations. These are all the transformations where the size of the shape does not change. So, AAS is a kind of way to compare your shapes, right? So, AAS would be angle, angle, side. So you have angle, angle, side, which means if I had two triangles or two of any shape, my angle would both be congruent. The angle next to it, an angle would be congruent, and then you would have the side, which would also be congruent, okay? So your little tick marks, those are how you're going to tell. Then you also have angle, side, angle. Same thing if you have two triangles that are congruent. You have your angle, your side, and your angle. Your angle, your side, and your angle. In both triangles, this angle and this angle are congruent. The middle side is congruent, and then the second angle and the second angle are congruent or the same. Then you also have side, 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 which is exactly what it sounds like. You have two triangles, all sides are congruent to the sides on the other triangle. You have side, angle, side, which two triangles, side congruent, angle congruent, side congruent. Then you have angle, 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 which is the same. All three angles are congruent. So you have this angle is congruent with this angle. this angle is congruent with this angle, and this angle is congruent with this angle. And then you have angle, angle, which is when two triangles, this works with triangles. If your two triangles have two angles that are congruent, so this angle is congruent to this angle and this angle is congruent to that angle, we know that the triangles are similar because these angles will also be the same. So now we have concept A, congruence and similarities. Shapes that are congruent are exactly the same, such that you can move one on top of the other and they have the exact same alignments. So they are exactly the same. Make sure you remember that. That is important. Shapes that are similar, so this is for congruent. Shapes that are similar are enlargements or reductions of the other shape, which means they won't be the same size. So in the extra part, shapes can be congruent even if you have to rotate, flip, or reflect. So here's some key things you need to remember. Congruent are rotations, reflections, and translations. Similar are similar triangles are dilations. Meaning they're made bigger or smaller. What is the difference between congruent and similar, but not congruent? Sketch examples of each. So for your first example, we could do similar but not congruent would be, we have two triangles. You could have a side of 1, 2, 3, and a side of 2, 4, 6. These are similar, but they are not congruent, meaning all your sides are not the same. If you have two congruent or similar, you have two triangles that are the same exact size. Actually, but maybe they are rotated. So you have this angle and this angle are the same. You have this angle and this angle that are the same, and this angle and this angle are the same. Okay, so you can see that my drawing is not perfect, but basically those triangles, if they were laid on top of each other, would be the same. So all circles are similar to one another. Their size is based on their radii. So basically what that means is that a circle is similar to another circle no matter what, right? You can always figure out a scale factor because a circle is perfectly round. All equilateral triangles are similar. this being your key word, equilateral triangles are similar to one another because an equilateral triangle always has 3 sides that are the same. So, another thing to think about, squares. All squares are similar. So if I were to draw a square, my square inside it, these are all similar, right? Makes sense. All squares, all 4 sides are the same. So, another little hint is octagons. I can't draw an octagon for my life, so please don't judge my terrible octagon. Yeah, this is that. Good thing. Let's see. Can I? Nope. Can I input? Okay, I'm just going to do my best. Please don't judge me. So, if I were to draw another octagon, within this, it would be similar to the first one. All regular polygons are similar. So, practice for number 1. It says the 2 shapes are squares. It wants you to find the x and scale factor. So, we know that this number right here is equal to this number because it's a square. So 2x minus 8 equals 24. This is step 1, right? So we're going to solve for x. We get 2x equals 32. 2x, x equals 16, because we're going to divide by 2. So, if x equals 16, now your step 2 is to solve this equation. So, we have 2x minus 8 equals, and this is what we're solving for. I guess in reality, we didn't actually need to do all this work, but this is how you would do it. So we know that e equals 24. If 24, that's a good way to check, is the top, right? And 12 is the other side. Your scale factor is going to be 24 divided by 12. This is shape 1, shape 2, which equals 2. That is your scale factor. It is being enlarged by 2, okay? So, similarity in other shapes. Is it always going to be that simple? Probably not. If the shapes are similar, then the sides are in proportion. There is a constant scale factor and a constant proportion between pairs of corresponding angles. So if you were to draw, and again, mine is not going to be perfect because, well, I'm not an artist. But if you were to draw two shapes, and we have 1 and 3, we'll label these. And then so, if you look carefully, 5x minus 7 is the same side as your 1. So you would set this up as a proportion. So you have 3, which is right here, and 9 are also the same. So you have 3 over 9 equals 1 over 5x minus 7. You are going to cross multiply. So you get, when you cross multiply, you're going to get 9 equals 3 times 5x minus 7. Now you're just solving for x. So 9 equals 15x minus 21. 9 add my 21 to both sides. You get 30 equals 15x. X divide by 15. Divide by 15. You get 2 equals x. Once you have solved for x, or now that you have solved for x, you know what x equals. You have two options. Bless me. Sorry, guys. So you can put in your x in this equation. So 5 times 2 minus 7. 5 times 2 is 10. You get 10 minus 7 means 3. That is your 3 equals line HG. And then you can set it up, well, this side divided by that side. So 3 divided by 1 equals 3. That is your scale factor. Okay, so some skill practice. We're going to do one more. Looking at the pictures on the left, we have 3x minus 9. A to D is the same as G to H, so over 15. Then we have 5 and 1. Make sure that your numbers are staying in the same order. So if you're doing the numbers from this on top, then both numbers from this one have to be on bottom. Okay? So cross multiply. So you're going to cross multiply that and that, which will get you 5 times 3x minus 9 equals 15. 15x minus 45 equals 15. 15x equals, you're going to add your 45, 60, x equals 4. So now that I know what my x is equal to, I can find out my my scale factor by putting it into this. So I'm going to put my x into 3x minus 9. 3 times 4 minus 9. 3 times 4 is 12. Minus 9 is 3. 3 over 15, or 15 over 3 equals 5. Your scale factor is 5. Okay, so on to the next one. So, you can work the relationship backwards if you need to. Corresponding angles are congruent and corresponding sides are in proportion. Then this shapes are similar. So, we're going to actually go straight down to the skill practice because it's a little bit easier to see than having me draw a crazy shape that doesn't make sense. So, if you were to look, are the shapes similar? Well, we're going to start here and we're going to go clockwise around to C. Okay, so first angle, 1 over 2. Equals, clockwise, we're going to go to the next one. One over 2. Now we're going to go to the next one. One over 2. To the next one. Oops, I missed this side. Would equal 1 over 2. Do you see? So far, all sides are equal to one another. Or in proportion, right? They're in proportion to each other. Because you have side 1 over side 2, side 1 over, or side 2 over side 2, side 3 over side 3, side 4 over side 4. So the ratios are consistently proportionate. They are 1 to 2. Your ratio is now 1 to 2. All sides are proportionate. But here's where it gets a little crazy, right? Now we need to look here and here. If all of the angles in the first shape, in this shape right here, are 120 degrees, but in the second shape we see that we have a 60 and a 150 degree angles, are your angles congruent? Your angles are not congruent, so your shape is not similar. If your shape was drawn with the same angles, then they would still be similar, okay? So looking back at the top, just to remember, the corresponding sides are in proportion and the angles are congruent, then you are similar, okay? So, Similarity in triangles. So again, this is where knowing your different side, angle, side will come in handy for you, right? So if two non-regular triangles have the same three angles, then they are similar. The scale factor is the ratio of the corresponding pairs of the sides, but the more interesting question is how little information do you need in order to conclude if two triangles are similar? So, if you look at the teacher notes, you will see three triangles. As long as you have at least 6 pieces of information, so whether it be 3 angles, 3 sides, a side and an angle, 2 angles and a side, whatever the plan you uses, you can tell, right? But you can also sometimes tell if it is an equilateral triangle, and you know 2 of your angles, then you know that they are similar, okay? So generally, oops. Six pieces of info. Three from each triangle. So you have side, side, side. If 3 sides are in proportion, the triangles are similar. You don't know anything else about the angles. That's fine, you know, because you know all 3 sides. So if you did 4 over 12 is equal to 4 over 12, which is equal to 4 over 12. Just by looking at that, you can see that all those ratios are the same. Oops. So, just by looking at this, you can tell that your first 2, these 2 are the same, right? But what about 7 to 21? Well, think about it. Can I turn my 4 into a 12? Yep, I'm going to multiply by 3, right? Can I turn my 4 into a 12? Yep, I can multiply by 3. Can I turn my 7 into a 21? Yep, I can multiply by 3. That shows you that they are still same because it's 3 times larger than the other triangle. So that is the way to remember. It is impossible to draw a triangle with different angles if they are like this triangle with different angles, okay? So the similarity would be side, 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 or SSS. So let's go to our practice problem. We have 35 over 21. We have 25 over 10. And we have 20 over 15. You can do it either way. It doesn't matter if you put the bigger number on top or the little number, whatever's easiest for you. So, can you divide 35 into 21? Or what? How do you simplify that fraction, right? So, 35 into 21. Does 7 go into 21? Yep, we know it's 3. Does 7 go into 35? It's 5. So, What about 25? How many times does 10 go into 25? Well, you would have to just simplify, right? Because it's not even. So you would have 5 or 2, I mean. Divide both sides by 5. So you get 5 over 2. And then same thing here, you can divide both sides by 5. You get 5 over 3. Look at all 3 fractions. Are they the same? Nope. This one is not the same as the other, which means your sides are not in proportion. These are not similar. Okay, so now we're going to learn about side, angle, side. Side, angle, side. If 2 pairs of sides are in proportion and their included angles are congruent, then the triangles are similar by side, angle, side. So let's go look at our first skill. If A is 22.5, find X. So, first things first, we need to figure out, are they similar, right? So, this is 75, this is 75. We know where our angles are. So that means 15 over 10. 21 over 14. This is our side, our angle, and our side. So if these two are congruent in size, then they can be similar triangles, and we're able to set up our proportion to equal A over X, or 22.5 over X, okay? So let's look at our first side. This would be 3 over 2. Divide each side by 7. You have 3 over 2. So that checks out, right? So if you do 3 over 2 equals 22.5 over X, we can solve. You get 45 equals 3X. X equals 15. And that is how you're going to answer your question. Okay? So then you have angle, 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 and angle, angle. The sides will turn out to be in proportion if you give some sort of side value. You can find the others by writing in the proportion. In fact, you also know the sum of the angles in a triangle is 180 degrees. So if you know that 2 angle pairs are congruent, you can find the third angle in each triangle. And that pair will be congruent too. Therefore, 2 triangles that have 2 congruent angles are similar by angle, angle. So this is how this works. Remember, when you have 2 angles or 3 angles in a triangle, all 3 angles equal 180 degrees. 3 angles in a triangle, only a triangle, equal 180 degrees. If you know 2 are congruent, the third will be as well. So, looking at our next question, we have angle, angle, angle theorem, right? So, thinking about our angle, angle, angle. If we look, we have 38 here, 38 here, 82, 82, 60, 60. Right there, we know all angles are congruent, and that means they are similar. So, concept D, congruence. Congruent figures are the same shape and size, such as that one exactly overlays the other, meaning size does not change at all. Generally, for polygons, you would need to know that almost all of the pairs, sides, and angles are congruent, okay? So just some key information right here. Make sure you remember this stuff, it is important. So we are going to do an application problem together because some of you have had some issues with these problems on the test or the assessment part of it. So Leah's shadow is 16 feet long, and the 10-foot tall flagpole she is next to casts a shadow of 40 feet. How tall is Leah? So think about it. If you have a 10-foot long or a 16, start with the first information. So we need to know the shadow is 16 feet long, the 10-foot pole casts a 40-foot shadow. So that means the information we do not have yet is Leah's height, right? So x over her 16-foot long shadow, because we know her shadow is 16 feet long, equals the 10-foot over the 40 foot. So 10 feet over 40 feet. And now you're just solving for x. So 16 times 10 is 160 feet equals 40x. Divide by 40. Divide by 40. X equals 4 feet. Leah is 4 feet tall. A map has a scale of 4 centimeters to 18 kilometers. Hillard and Arlington are 9 kilometers apart. How far apart are they on the map? Well, again, they give you the information you need. So right here, that's your scale factor, right? So 4 centimeters to 18 kilometers. Make sure you're looking at whatever unit it is using. Those need to be in the same place. X over 9 kilometers. So you do 4 times 9 equals 18x. 4 times 9 is 36 equals 18x. Divide by your 18. X equals 2 centimeters, because we know that this is a centimeter, okay? I hope that helped you guys out. I hope you're having a wonderful weekend, and I will talk to you all soon. Have a great day.